Hello, my name is Darren Thomas. I am the Director of Educational Research Techniques. In this video, we're going to introduce some of the basic ideas behind right triangles and trigonometry. So let's go ahead and get started. Alright, so right here I have my unit circle and I have my triangle inside it, and I'm pretty sure you guys are familiar with some of the basic ideas that we've covered here. So inside the unit circle, the length here of the hypotenuse, if you will, is 1. And we often want to find the coordinates of the x and the y. And so this is all background information. Now, the thing is that we're not always bound to the unit circle. In other words, the ideals of sine, cosine, tangent, cosecant, secant, cotangent, etc. can be captured without the unit circle. But before I get there, let me try to explain kind of what's going on here. So you know that we have our angle T here. Angle T right there. And so you know that the cost T is going to be x. But we can also say, and we don't normally do this because you'll know why in a second, it could be x over 1. Now, why do I say x over 1? Well, here's because what's happening is that this distance from here to here is kind of the x. So this is the x right here, and this distance from here to here is kind of the y. And so if I think in terms of this ratio x over 1, well, I'm going to go to my x and I'm going to get the answer because this x right here is the same as x over 1. Now, why do I say 1? Because that's the length of the hypotenuse. In other words, and this is just kind of a foreshadow of what we're trying to talk about, cosine can be defined as, when you look at it from the perspective of angle T here, it could be defined as the adjacent side here, so A, over the hypotenuse of 1. That's kind of what's happening. And so when you understand this, you can remove yourself from the unit circle and use these same ratios in all these other different situations. So if I want to talk about my sine now, sine of t, well, we know that's y, but we can also say y over 1. And so what is y over 1? Well, again, that's this guy right here, the y and the 1. So why do I say 1? Because that is that length right here, okay? Because y over 1 is the same thing as y. That's why I'm saying that. And so if we look at it from that perspective now, this side right here is opposite. It is opposite, so sine of t, if you will, opposite over hypotenuse. That's kind of what's happening there. And so you can see how these things all work out and how they're interrelated. And understanding this, you can do much more. So let's go to the next slide. So if I want to draw me a nice, big, huge triangle, let me see here. I'll draw me a nice big huge triangle, nice and big, and oops, then like so, and then I want to make sure these touch. There we go. And then right here, and then I want to make sure these touch like so. All right, that's kind of like a right triangle. It's never drawn to scale when I draw it. So when we're dealing with our right triangle here, and so we got our A, our O, this is going to be our right angle here, and then our H, and this is all from the perspective of angle T here. Now this is what we kind of have. So sine of T, like I already told you, sine of T, excuse me, I forgot that, is going to be opposite over hypotenuse. And that means that cosine is going to be adjacent over hypotenuse. And that means tangent, remember tangent used to be, what was tangent? Tangent was y over x, or it used to be sine over cosine. Well, that's one way to think about it. Oh, excuse me. Sine over cosine used to be sine over cosine, but another way to think of tangent is opposite over adjacent. Opposite over adjacent, because remember, this length right here is the y anyway, is y over 1, and this length right here is x over 1. We saw that on the previous slide. So you could think in terms of sine over cosine, or you could think in terms of y over x. They both work interrelatedly. And again, we're able to step away from the unit circle when we do this. Now, this right here, sine opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. A little acronym for this is SOHCAHTOA. That's what they like to use a lot when you're talking about trigonometry and things. And so now for the last trick here, I want to just show you, just draw this quick, have a nice little basic circle here, or excuse me, not circle, triangle, sorry about that. And so if I make my little simple circle or triangle again, I didn't make the same mistake. So I got angle T, it's a right angle. And so let's see here, we'll have a length of 10 here, a length of, no, that's not gonna work. Just do 3, 4, 5. So 3, 4, and 5. And so now we have numbers to put with this. So if I wanted to figure out what is sine of t, well, let me just put my little acronym here at the bottom. Let's see here. So, ga, to, wa. So if I want to figure out sine of t, sine is opposite over adjacent. So opposite is 3, adjacent is 4. That's going to be 3 over 4. The ratio applies. If I want to think in terms of cosine, what's cosine of t? Well, cosine of t, that's going to be adjacent over hypotenuse, 4 over 5. I want to think in terms of tangent. Tangent is opposite over adjacent. Wait. Opposite, oh, I made a mistake up here. This should not be, sine should be opposite over hypotenuse. Excuse me, this is 3 over, oh, this is 3 over 5 up here. And so this TOA is going to be opposite over adjacent, so 3 over 4. And now for the other trigonometric functions, which you know that there's many more of these, we can go on and on and on. So for secant is going to be hypotenuse over adjacent, or the opposite of sine, if you will, the inverse of sine. So 5 over 3, is that correct? Secant, yeah, opposite over adjacent, 5 over 4. So secant is the reciprocal of cosine, excuse me. And so cosecant, CSC, cosecant is going to be hypotenuse, so that's 5 over opposite, that's 3. And so that's the opposite of, that's the reciprocal of sine, if you will. And then of course we got cotangent, cot, and so that's going to be adjacent over opposite, so that's going to be 4 over 3, or you could say the inverse of the reciprocal of tangent. And so that's how it works. And so this lays the foundation of extending our experience with these trigonometric functions beyond the unit circle and being able to apply them in a lot more examples of real-world applications. So let me kind of summarize what we talked about and conclude the video. So in this video, we talked about right triangles and trigonometric functions. And so what we are trying to illustrate here was that these ideals behind sine and cosine and tangent, they're just ratios. And so we can extend our understanding of how they apply in the unit circle to any general right triangle. And so in this particular slide, I kind of showed you how you were able to come up with the little acronym here, SOHCAHTOA, by understanding the position of the adjacent, the opposite, and the hypotenuse with a right triangle. Now, having talked about that, I gave an actual example using real numbers here for all the different trigonometric functions and the actual ratio that they would have if you had, real numbers. And then I extended that by talking about the other trigonometric functions, secant, cosecant, and cotangent, and how they're just, reciprocals of the other main three, sine, cosine, and tangent. So I hope this video was, clear and you were able to understand what we were talking about. My name is Darren Thomas. I am the Director of Educational Research Techniques. Take care.